In this lesson, we will implement iteration by the use of a while loop. What we are observing right now are several comments on how to establish or how to structure the loop. One is to prime the loop. Next is to evaluate through a condition so that we will remain or not remain in the loop, and then we need to be able to exit. So let's write the code for that, and then we will do a flowchart to re-emphasize again those steps and see them visually. So for now, let's write the code. Let's suppose we have a variable and we give it a value 5. Okay? Now we want to enter or not enter a loop based on that value. Now we have seen this. If x, for example, is greater than 5, then that would be an if statement. Okay, so this will yield obviously a false. So if we were to do this, and let's say we set print x and or else, so this could be a review for if statements, print the condition was false, and it's true here in this case, right? And let's go ahead and run this for a minute here. So let's go ahead and run, and you could see the condition was false. And the reason again is that because x is 5 and this here is the comparison from which we evaluate the condition. Is x greater than 5? The answer is no. So we will be doing this. So now, can we convert this if into some other form or some other structure where we create a repetition, or we force the block of code that we would have here to repeat itself if it remains true? The answer is yes. So we could replace this with while, and that's the syntax that you would use. And as long as this is true, you will execute this. So let's go ahead and say print the body of the loop. So we're looking at the body of the loop, and then shows, we could do something like this, the present x value, and then we could go ahead and print x if we want to. Okay. Now, what would happen in this manner? Well, first of all, let's see what happens if the condition is actually true. Let's go ahead and make it equal to 5 or equal 5. So we're comparing, is x. As long as x is 5, then we're going to be seeing this. So let's go ahead and run this. And notice what happens when you do something like this. It will loop to infinity. And the reason is because it's always true. While x equals 5, the body of the loop show, or I should say here, shows the present x value as being 5. So let's kill the program for a minute. Here you go. And shows, there you go. Let's put an S there. Right? That would be more proper. So what can we do? Well, you need to be able to alter the value of x if you want to be able to exit. So something has to happen. So let me write here another comment. Control the loop condition. So we need to have control over the loop. Okay, so how do we do that? Well, within the body of the loop, maybe we would ask the user to re-enter a new value for x. Maybe something like this, x. Now remember, x is an integer, so we're going to typecast to the input function. So whatever the input function returns, we will typecast it as an integer, and we will ask the user to re-enter the value of x. Okay, well, that gives us some control. Well, let's see how that works. So let's run it. And you can see here, the body of the loop shows the present x value is 5. Great. Well, let's enter 5. Again, we could see as long as we're evaluating against 5, we're good. We stay in the loop. Now, let's put 4. As you can see, 4 will kick us out. And the reason is x is not equal to 5 since it's 4. Now, how do we know we're outside the loop? So now let's write this statement, and notice the indentation. This is not part of the block for the loop. What I mean by block is all this code, notice it's indented, right? It's because it belongs to the true block of the while statement. So let's go ahead and do something like this. We're outside the loop. Okay, let's run this again. And let's give it a value of 5. So as long as we enter 5, we stay in the loop. Now let's go ahead and put an 8. And sure enough, we're outside the loop. So from a visual point of view, what just happened? And let's go ahead and look at a flowchart. So let's go ahead and draw what just happened right now. So let's start the program right here. And we assigned the value of x equals 5 as an integer. So we did that as an initialization. Then what happened? Then we evaluated. So what I'm going to do here is put a connector. This is the flow line. And then we asked a question to evaluate. Was x equal to 5? The answer is either true or false. So if it was true, then what we did is we printed out, we printed the value of x. And then we asked in to change the value of x. So these are input outputs. And then what happened? Well, we came back to this connector. If it was false, then we printed some message that we're outside the out of the loop, or outside the loop, right? So, and this is again a print statement, and we ended the program in this manner. So what are the various components in this flowchart? This here was the priming. And this here was the evaluation of the condition. And this here was the control of the loop. Without it, we will remain in the loop. So if we could not alter, so this here allows x to be altered or changed, right? This simply here displayed x, but this was the important part, which means if we could not alter x, then we would be looping here, right? So this is a loop. We would be looping here because x will always be 5, since we've entered the loop by evaluating was x equal 5. Sure enough, because we've primed it to 5. Okay, let's look at the code again. And so we've primed it to 5. We evaluated, is it 5? The answer is true. And then we printed it. But if we did not have this is the control of the loop, then we would remain in the loop. But because we had the ability to change the value of x while we were in the loop, this allowed us to exit. Okay, so without this statement here, which is critical, or this process here, we would never be able to get out of the loop. Okay, so now in terms of comparison, can I change that from being equal to greater, for example, or some other form? The answer is yes. You could do a whole bunch of things here. So if you run this again, notice right away, you set x to 5, then this is false. The body of the loop will not be executed. So we're outside the loop right away. So the loop does not have to execute right away. It's a matter of what do you set x to here. So can we change the prime of the loop and have a little bit of control here? Sure, we could do something like this. X equals int input, enter a value for x, right? So we could do that. And now let's see how this program works. So we could do something like this. So let's say I entered 4. So the answer is now, is x, is 4 basically greater than 5? And the answer is no. So we're outside the loop. Now let's run it again and let's enter a value that is greater than 5, for example 6. And you can see the body of the loop shows the present x value is 6. That is because the condition is true. But notice now I have the very important line where I'm asked again to re-enter the value of x, which is the control line or the control process that I need to be able to get out. Well, let's say I don't want to get out. Let's say I print 7. Well, 7 is greater than 5. So notice we will remain in the loop. Now let's get out of the loop. Let's put 3. So now we're in total control when we stay and when we leave. Because of this loop control statement. And obviously every line is important, but this is extremely important in case you want to have control over the loop to either stay or leave.